Hello. This is the last day of Unit 2, or Chapter 2, I should say. And the first thing I want to remind everybody is to never use calculator words on a test. Calculator words are words like normal, CDF. Now, not everybody uses the same calculators, and this isn't statistics terms, this is a calculator term. So whenever you run into a calculator term, make sure you don't use that on the test. AP doesn't like it. All right, now I'm going to teach you a little bit more about using the calculator, more than AP actually would prefer you to know. The test scores for an AP Stats class are approximately normal with a mean of 24 and a standard deviation of 3. Find the percentile for the person who scored 22 points. Well, the first thing we should do is draw out a nice normal curve. If the mean is 24, the standard deviation is 3. 22 would be like there and below. Percentile is that and below. All right, wonderful. So if I had to guess, I'd say maybe 30%. I don't, just from the graph, we can take a guess. But what we want to do is we want to find the probability that it's below 22. The probability that's below 22 is the probability that my z is below 22 minus 24 over 3. So that's the probability my z is less than negative 2/3. So to do that on the calculator, we hit second vars, we go to normal CDF, and less than, we're going from negative infinity, so negative big number, to negative 2/3. And when we do that, it's 25%. So 0.2525. No, I guess 30%. I guess 25% is exactly what it would be. So that's a decent guess. If we, let's take a look at that one more time. Now I'm going to show you an easier way to get this. This is what how AP would like you to answer the question. Your calculator can do more than that. Now, if you didn't want to go through these steps to find the z-score, what we could do is just type in the x variables right in your calculator. So we could do normal CDF. We want everything less than 22. So let's pick a very big number, like negative big number, all the way up to 22. Now we can't stop there. We have to put in a mean and then a standard deviation. And we get that same value, 0.2525. So you can skip the z-scores if you put in the mean and standard deviation. So if I was going to do this next one, find the percent of people who scored more than 19 points, what I would do is I'd do my normal CDF. 19 is the smallest number, and it's going to go up to a big number, and the mean is 24 with a standard deviation of 3. So 0.9522. So 95.22% of the people scored more than 19 points on that test. Now, if I was going to answer this question on a free response portion of a test, or on the AP test, of course, you'd want to draw it out, do the probabilities, but here we can go straight to the answer. However, if I wanted to find it, the percentile for the person whose z-score is negative 1.72, z-scores, we just use the two numbers. So if it was z-score, I'd go from negative big number to negative 1.72, and that would be 0.0427. So about 4% of the people have a z-score less than negative 1.72. If I wanted a z-score between negative 1 and 1.5, I do normal CDF between negative 1 and 1.5, and that's 77.45% or 0.7745. So here are some notes. If it's standardized, you do normal CDF, min, and then max. If it's not standardized, and remember standardized means z-scores. If it doesn't give you the z-scores, you can do min, max, mean, and then standard deviation to find the probabilities. Now, if we wanted to go in the opposite way, we use inverse norm. So if you have z-scores, or if we're looking for z-scores, you do inverse norm percentile. If I don't have the z-scores, I can do inverse norm percentile mean standard deviation to find the specific answer. For example, if I want to find the z-score for the 43rd percentile, I press second vars. We do inverse norm. It does, remember inverses do the opposite of the regular function, so the opposite of normal CDF. Inverse norm 0.43, not 443. So my z-score is negative 0.176. That's supposed to say z-score. All right. Now, same type of problem. We have the AP Stats class with a mean of 24, standard deviation of 3. Find the score that's in the 90th percentile. So if I drew this out, 90th percentile would be like over here somewhere. And we'll want to shade all of this in. So you scored better than most people. This mean is 24 and the standard deviation is 3. So I could just do inverse norm 0.9 comma 24 comma 3. So this point right there would be 27.84. So a person who scored 27.84 or above would be at least in the 90th percentile. All right. Now, when we are assessing normality, there's two methods. Now, this gets back to our note sheet. There's two methods for assessing normality. First one is to create a box plot and look for outliers and skewness. The second one is to create a normal probability plot. Now, that's a new plot that you probably haven't seen before. And when we do that, we look for linearity. So we look for a straight line. So let's plot these data points into our calculator, and then we can use both methods to assess normality. So pause it, and then type them in. Now that I have these values typed into my L1, then I will go to my stat plot. First, I'm going to turn it on. And now look to see that there's two box plots on here. The first box plot is a modified box plot where it puts dots for outliers. The second one is just a regular box plot that won't do that. So let's look at my modified box plot. Hit zoom 9 to get a good window. Oh, I have something in my y equals that I can get rid of. All right, wonderful. Now if I hit trace, it'll give me my minimum, Q1, median, Q3, and maximum. So this looks reasonably symmetric. So method 1, that's symmetric enough to say that the data is approximately normal. Now the second method is to use the normal probability plot, which is just up in here. And what we do is we go to the very last graph. No one has probably used this one before, unless you've taken AP Stats before. Normal probability plot, my data is in L1, and the data axis is the x-axis. So if we hit zoom 9 again, now this will be a different plot altogether. And what we look for here is a linear relationship. Does that look like a linear relationship? It looks pretty good. It looks like a might curve here. The endpoints might be a little bit off, but it's pretty linear. I think that looks a little bit better even than what my previous one was. All right, so both of these say that the data is relatively linear. So, or this is linear, this is symmetric, so we can say that it's approximately normal. What the normal probability plot does is it plots your x values. So you take all of the x values and it plots them against their z-scores. So this is z-score. Now, I'm never going to make you do one of these by hand because what you have to do is convert every single value to a z-score, which would take a really long time. So I'm not going to have you make a z-score, plot it, make a z-score, plot it. Um, it just takes too long for what you get out of it. So here we'll just use our technology. Now, this is a little bit more description on the normal probability plots. If the points on a normal probability plot lie close to a straight line, the plot indicates that the data are normal. Or maybe if it's close to a straight line, we should say approximately normal. Systematic deviations from a straight line indicate non-normal distributions. Outliers appear at the points that are far away from the overall pattern of the plot. All right, so if we look at this one is relatively linear. So we'd say this is normal. This next one, you can see some obvious curves, so I'll say non-normal. This one still looks pretty normal because it has a linear relationship. However, this one you can see there's a curve, so we'll say this is non-normal. All right, now here's your homework. Good luck.